1.8, solving equations by adding or subtracting. We're going to learn to solve equations now. We're moving on from expressions and combining them into equations. So the two vocabulary terms are equation and inverse operation is how we're going to solve these. An equation is a mathematical sentence that uses an equal sign to show that two expressions have the same value. All of these are examples of equations. 3 plus 8 equals 11, r plus 6 equals 14, 24 equals x minus 7, 100 divided by 2 equals 50, all different types. To solve an equation that contains a variable, find the value of the variable that makes the equation true. This value of the variable is called the solution of the equation. There's a couple ways to do this. The first set of examples we're going to look at, the book is going to give you numbers to substitute in, and you just have to try those to see if it makes a true solution. So determine which value of x is a solution of the equation. Make sure and check all of the values in case there's more than one solution. So our equation is x plus 8 equals 15, and I have to try 5, 7, and 23. So let's just substitute the first value of 5 into my equation. So if I put in 5 for x, I have 5 plus 8, and I have a question mark. Is that equal to 15? So if I go ahead and solve the left-hand side of 5 plus 8, I get 13. 13 is not equal to 15, so 5 is not a solution. If I move on to substitute 7 for x, now I have 7 plus 8 on the left-hand side of my equation. Is that equal to 15? So if I add those together, I get 15 equals 15, which is a solution. So 7 is a solution, I know that. So I pretty much know that 23 is not going to work in this case, but you can have equations where you will have more than one solution. In an addition equation, you rarely will have this. So I'll go ahead and plug in 23 plus 8, combine that to get 31, which is not equal to 15, so 23 is not a solution. Addition and subtraction are inverse operations, which means they undo each other. It kind of relates back to additive inverses, where an additive inverse of 6 would be negative 6, or an additive inverse of negative 3 would be 3. What can I combine to kind of cancel out and get back to 0? And that's what inverse operations also do, is they cancel each other out or undo each other. To solve an equation, use inverse operations to isolate the variable. In other words, get the variable alone on one side of the equal sign. To solve a subtraction equation, like y minus 15 equals 7, you would use the additive property of equality. That means since subtraction is being used in my equation, I want to use the additive property to undo that. So that means I can add the same number to both sides of the equal sign, and the statement will still be true. So there's a couple of examples using numbers in algebra there. It's like a teeter-totter or a balance. Whatever you do to one side of the equal sign, you have to do to the other side of the equal sign to keep that balance. If I had an expression like x plus 9 equals 11, to solve that, I'm going to use the subtraction property of equality, meaning to undo that addition and isolate x, or isolate my variable, I'm going to subtract something from both sides of my equation. So on both sides of that equal sign, the statement will still be true. So there's an example with numbers. I subtract 3 from both sides, I still have a true statement, and then it shows you with algebra using variables. So let's go ahead and put these into practice. Solve 10 plus n equals 18. Since addition is being used in my equation, I'm going to use the subtraction property of equality. Whatever's being done to my variable, so in this case 10 is being added, there's no plus sign in front of that 10. It's understood to be positive, so to undo that positive I have to do a negative or subtraction. So I'm going to line up my 10s. I'm not going to try and combine 10 with n. Those are unlike terms. That would be like combining apples and oranges. So if I do that on the left-hand side of the equal sign, I also need to do that on the right side of the equal sign. Then I just perform those operations. Plus 10 and minus 10 are additive inverses. They go to 0, so I'm just left with n on the left-hand side. 18 minus 10 is 8. My 0 can go away because of my identity property, and I'm just left with n being equal to 8. Now I should probably go ahead and check this. I'm going to take my solution of 8 and plug that into my original equation. 10 plus n equals 18. Substitute n, or 8 for n. Is 10 plus 8 equal to 18? Combine those, check. Yes, it is. Okay, another example. P minus 8 equals 9. Because subtraction's being used, I'm going to use the additive property of equality to undo that. So at the negative 8 or subtracting 8, I'm going to add 8. Also do that to the right-hand side of my equal sign. If I go ahead, my negative 8 and my positive 8 cancel out. P plus 0 equals 17. Because of the 0 identity property, my 0 can go away and I'm left with P equals 17. That's my solution to my equation. So now I'm going to take that and substitute it back in for my check. Substitute 17 for P. So is 17 minus 8 equal to 9? Do the arithmetic. It is, and I can check it. Another example of this. This may not be on your notes worksheet. 22 equals y minus 11. Since subtraction is being used, I'm going to use my additive property of equality and add 11 to both sides. Notice how I continue to just line up my constant terms. My variable is left alone. So my negative 11 and positive 11 cancels out, and 22 plus 11 is 33. Again, 0 property, so y equals 33. Let's check this by substituting 33 back into y into my original equation. Is 22 equal to 33 minus 11? Do the arithmetic. It is. I can check it. Word problem. This gets a little long because we go into some detail here. In your homework, it doesn't have to get this lengthy. Jan and Alex are arguing over who gets to play a board game. If Jan, on the right, pulls with a force of 14 newtons, what force is Alex exerting on the game if the net force is 3 newtons? That means it's a little bit of a tug of war and it's not balancing out. We're having this positive 3 newtons, which if Jan already has positive 14 newtons, that means Alex is going the opposite way. His is going to be measured as a negative. This just explains what a newton is. It's capital N. It's a measure of force, positive to the right, negative to the left. So the answer is the force that Alex on the left is exerting on the board game. List the important information that I was given. Jan on the right pulls with a force of 14 newtons. The net force is 3 newtons. Show the relationship or the information. So my net force is whatever's left over between Jan and Alex. So I'm going to add Jan and Alex and get my net force. So I'm going to write an equation. My net force is going to be on its own on one side of the equation. And then, so that's the 3 newtons. And then I've got Alex's force and Jan's force. So I have 3 equals F plus 14. And I'm going to find out what Alex's force is on the board game. So since addition's being used, let's undo that using subtraction. So subtract 14 from both sides of the equal sign. I'm left with negative 11 is equal to the force of Alex. Keep in mind, negative in this case just means that it's a force being pulled from the left. So Alex was exerting a force of negative 11 newtons on the board game. Let's go ahead and check it. One way to check problems like this is to put them onto a number line. Check the answer by using a number line. Move 14 units right to show Jan's force. So I started at 0, I went 14 to the right to show Jan, and now I'm going to move 11 units to the left to show Alex's force. And let's just see if that lands me at 3.